Welcome to AI Paper Drop. I'm Alex.
And I'm Maya.
What if the AI agent you use to write code or organize your calendar is already a world-class robot operator without ever having been trained on a single piece of hardware?
That sounds like a stretch. I mean, writing a Python script is one thing, but actually moving a physical arm in 3D space without knocking everything over is a completely different beast.
Right? And that's exactly the wall we've been hitting for years. If you want a robot to do something new, the standard play has been fine-tuning. You feed it massive amounts of specific robot action data. You train it for weeks, and you pray it works in the real world.
But that's the problem with fine-tuning, right? It's too rigid. If the light changes or the object is 2 inches to the left, the robot basically has a meltdown because it's only as smart as the specific data it was fed.
Exactly. It is a data bottleneck. We have these incredibly smart frontier models, these giants of reasoning, but to get them into a robot, we usually shrink them down or strip them of their general intelligence just to fit the limited robot data we have.
So we're basically taking a genius and forcing them to act like a specialized calculator. There has to be a way to keep the brain and just change how it talks to the arm.
And that is exactly what this paper, VIA, proposes. VIA stands for Visual Interface Agent. The big idea here is stop trying to teach the AI how to be a robot, and instead give the AI a software interface to control the robot.
Wait, so you're saying it doesn't actually talk to the hardware directly?
Nope. Think of it like this. Imagine you've never touched a robot in your life, but you're amazing at using 3D software like Blender or AutoCAD. If I gave you a screen showing a robot's view and a few buttons to move the gripper, you could probably figure it out just by looking at the screen and clicking things.
So the robot is basically treated like just another app? Like a browser tab?
Precisely. VIA sets up a browser-based 3D interface. The AI takes screenshots of the robot's environment, decides what needs to happen, and then issues intuitive commands through a small set of general tools. It's not thinking in joint angles or torque. It's thinking in terms of a user interface.
That's a huge shift. Because if it's just an agent using a tool, it can use all that general reasoning it already has. It can see, oh, I missed the bowl, and then just try again?
Exactly. It is a closed-loop system. It observes the outcome of its action in the screenshot and adjusts in real time. It's not following a rigid script. It's improvising based on what it sees, which is how humans actually use software.
I'm still skeptical about the precision, though. A browser screenshot is a bit low-res for something like picking up a needle or stacking blocks. How does it actually perform?
This is where it gets wild. They tested this with off-the-shelf agents. No robot-specific training. Nothing. Just Claude Code and Codex. And for 3 complex tabletop tasks, the strongest model hit a 96.7% success rate.
96%? Zero shot? Without ever being told what a robot arm is?
Right. And get this. They had a long horizon rainbow assembly task, which is basically a multi-step puzzle, and it hit 100% success.
Okay, that is actually wild. I was expecting it to be a cool proof of concept, maybe 60 or 70%, but 100% on a complex assembly task is a different story.
It's not perfect, though. They found that high-precision tasks, like stacking blocks into a T-shape, are still a struggle. It seems the agent can get close, but the fine-grained spatial reasoning is where the limit is.
That makes sense. But did it show any signs of actually thinking through the physics? Or was it just guessing?
It actually showed some impressive nuance. For example, when it had to pinch a bowl, it didn't just dive straight down. It followed natural language instructions to descend from the top and grip the bowl by its sidewall. It was adapting its strategy based on the geometry of the object it saw in the screenshot.
So the takeaway here is that the intelligence was already there. The AI knew how to solve the problem. It just didn't have a way to tell the robot's motors what to do.
Exactly. We've been trying to build the brain and the body at the same time. VIA suggests we could just plug a world-class brain into a simple, well-designed interface, and the body just works.
Which means the bottleneck isn't actually the robot hardware or the robotics data. The bottleneck is just the interface. If we make the interface better, the robot gets smarter automatically.
Right? As Claude or GPT or whatever comes next gets better at using a computer, they automatically get better at controlling a robot. We're basically outsourcing the hard part of robotics to the general progress of AI agents.
It really changes the vision of the future. Instead of spending years training a robot to fold laundry, you just give it a screen and tell it, hey, look at this, now do that.
It is a total paradigm shift. We are moving from programming robots with code to guiding them with conversation.
It basically turns the physical world into just another user-friendly interface. If you are enjoying this, follow or subscribe to AI Paper Drop wherever you listen. It really helps, and we have a new episode every day.
Paper by Hengyuan Hu, Priya Sunare-san, Jensen Gao, Dorsa Sadai, produced by AI Paper Drop.